Hello Algebra 1D students, this is a video on simplifying rational expressions. To think about a rational expression, right, we're talking about a polynomial over a polynomial with a division bar in between. And to simplify them, we really want to find things that can cancel in the top and bottom. So really the thing we need to talk about first is y minus 1 divided by y minus 1. What does that give us? Well, early on, maybe 3rd grade, 4th grade, we learned that a number divided by a number is 1, right? So a fraction, 2 divided by 2 is 1. So really, we're just looking here at the same thing divided by the same thing, which is actually going to give us 1 as well, okay? If you think about plugging in a number for y, you could think about plugging in 3 minus 1 over 3 minus 1, which just gives me 2 over 2, which we agreed was 1. So no matter what y is, y minus 1 is going to be the same as y minus 1. And if you divide the same thing by itself, you're just going to get 1 always. So we're going to use this idea to simplify these next couple examples here. If you want to take a second to pause the video and copy down these steps first, excellent. If you want to take a second to do the examples first and then come back to these steps, do that as well. Okay, so let's go ahead and look at this first example. Okay, we really want to pull out a greatest common factor. So if we look at the top here, ignore the bottom. I don't really see a common factor between 1x and 1, except for 1. That's not really going to change anything. So that one I can't really change. Let's look at the bottom. The bottom says 5x minus 5. You know what? Both of those have a common factor of 5. So I'm going to go ahead and sort of pull out a 5. And what I mean by that is I'm going to sort of divide 5 out front. And then what did I multiply 5 by to get 5x? Well, I multiplied by 1x. And what did I multiply 5 by to get negative 5? I got negative 1. Okay? So now you can kind of see we have 1x minus 1 on the top and 5 times 1x minus 1 on the bottom. Well, just like we set up here, if we have something on the top and something on the bottom, that gives us 1. Or, as we like to call it, they cancel out. Okay? And we're just left with this 5. Okay? But we can't just make it 5, right? Because it's 5 in the denominator, so we can call it 1/5. Okay? In this case, there are no excluded values because there's really not a variable here, right? 1/5 is the simplified form of this equation, so there's really not a variable to say it can't be this. So let's go ahead and look at the second one here. I have 2x minus 5 and 5 minus 2x. Now, let's look at the first one, okay? I don't see any GCFs that I can pull out from 2 and 5. Okay, let's look at the bottom. Ooh, at the bottom, I don't see any GCFs I can pull out from 2 and 5. But I look at both of them, and I see they're kind of like the same thing but opposite. So you know what I'm going to do? I'm going to go ahead and pull out a negative 1 from this one. Keep the top the same, and I'm going to divide everything on the bottom by negative 1, right? I'm going to factor out a negative 1. So what did I multiply negative 1 by to get 5? I had to multiply it by a negative 5. What did I have to multiply negative 1 by to get negative 2x? I had to multiply by a positive 2x. Ooh, okay. So now this is starting to look a little bit different. I can go ahead and rearrange this one on the bottom so that the x is first. 2x plus negative 5. And actually, 2x plus negative 5 is the same as 2x minus 5. Oh, hey, that worked out nicely because now you can see that I have a 2x minus 5 in the top and a 2x minus 5 at the bottom. Those will cancel out, and I will just be left with 1 over a negative 1 or negative 1. Nifty. Again, I don't have any excluded values because I don't have any, in this one I don't have any denominator, and I also don't have any variables. So let's take a look at this one here. I have 3x minus 6 and x squared plus x minus 6. Wow. Well, the first thing I notice is that on the top there, I could pull out a 3. That would give me x minus 2. And you know what else I notice? On the bottom, that's actually a quadratic expression, right? And we really want them to be linear pieces like this so that we can cancel them out. So let's go ahead and factor this expression. So I'm going to draw my box over here. I am looking for, well, this has to be x and x to make x squared. I'm looking for something that adds to 1x and multiplies to negative 6. I think I'm going to be using plus 3 and minus 2. That would give me negative 2x and and 3x, which gives me 1x. So I can rewrite this in its factored form, which is x plus 3 and x minus 2. Oh, hey, look, I noticed there's an x minus 2 in the numerator and an x minus 2 in the denominator. So if I cross those out and cancel those, that gives me 3 over x plus 3. Now, I really can't simplify this any further because I can't sort of like split up the 3 here. It doesn't really work like that. It only works with things that we're multiplying. But this case, we do have a variable in the denominator, right? And that means that we're going to have an excluded value. An excluded value happens when the denominator is equal to 0. Do you guys remember that old rule where you can't take a number and divide it by 0? You definitely can't, right? Even if you have 7 things, you can only put them into one group. There's no such thing as 0 groups. So that's why we say dividing something by 0 means it's undefined. It's not possible. And so we really don't want this to be equal to 0. Well, when is this bottom going to be equal to 0? Well, if x, and then we add 3, you know what I'm thinking? If x is negative 3, that would mean negative 3 plus 3 equals 0, and that's when the bottom would be 0. So x equals 3 has to be an excluded value. And in a few weeks, we'll talk about what that looks like on a graph. So this is our simplified expression, and this is an excluded value from that expression, because if I were to plug in negative 3 for x, that would give me something divided by 0, and I just can't have that. Okay? Excellent. Make sure that this has gotten into your notebook and that you have copied down all of the information.